Good morning, students. Today we are going to study about the crystal defects. These defects are also known as lattice defects. These are caused by the departure from the regular arrangement in the vicinity of an atom or group of atoms. These defects can be classified into three categories. One is stoichiometric defect. This defect is seen in the stoichiometric solids. Second is non-stoichiometric defect. This is observed in non-stoichiometric solids. Third one is impurity defect. This defect is seen in the crystal lattice when the impurities are there. Today in this video, we will be studying about the stoichiometric defect. Stoichiometric defects are those in which the positive or the negative ion, that is the cation in the anions, move from their original place and leaving the space behind. Now, a question arises in my mind. What is stoichiometric solids? Stoichiometric solids are those solids in which the number of cations and number of anions are exactly in the ratio which is indicated in the chemical formula. The defect in the crystal is by the missing of the cation or the anion from a particular place and leaving a vacancy or a hole in the crystal lattice site. This defect is known as the stoichiometric defect. These are of two types. One is Scotty defect and second is Franklin defect. These are the two types of Scotty defect and it is the Franklin defect. Now, first one, the Scotty defect. A Scotty defect is caused by the missing of the cation in the anions and leaving the space empty or leaving hole in the crystal lattice. This can be seen in this diagram. This dotted, the circle having the dotted is cation and this circle having the slanted lines is anion. If we see in this particular lattice, a cation is not here, which is not occupied its position. Similarly, here in anion has not occupied its position. So these two holes are there in the crystal lattice. Now, when these holes are there, since the number of the ions remains same, and these defects is observed in highly ionic solids. And when these are having the coordination number of these compounds is also high. This defect is observed in the compounds like sodium chloride, potassium chloride, potassium bromide, and cesium chloride. The presence of the high number of stoichiometric defect in the crystal lattice decreases in the number of ions. Thus, the lowering of the density is there. Now, we can see here NaC. Here the size of the cation in the anions are almost same. Second comes the Franklin defect. Now, Franklin defect is another part of the stoichiometric defect. Franklin defect, when a hole or a vacancy exists in the crystal lattice because an ion occupies an interstitial lattice site. This defect in the crystal lattice is known as a Franklin defect. This can be seen here. Now this is a crystal lattice in which the cation over here has been transferred or has left us a space to here to occupy the interstitial space between these two, and its size here or remains empty. Similarly, this cation here leaves its space and comes to the interstitial space here, so leaving a hole over here. Such type of defect is seen in the compounds which are having the different size. Generally here, the cation is smaller than the anion. For example, this defect is seen in silver bromide, zinc sulfide, and other many solids. Here, if I say this is silver and this is bromide, the silver leaves its space from here and it occupies here. And since there is no change in the number of the cations in anions, these lattices are also electrically neutral. But as these are occupying the interstitial spaces, hence the density of these compounds remains same. In Franklin defect, there is no change in the density. Now, in Scotty and Franklin defect, crystalline solid, the stability of the crystal lattice decreases, and thus a covalent character increases. And because of this increase in the covalent character, some of the solids conduct electricity. Now the difference between the Scotty and the Franklin defect. In the Scotty defect, both the ions, that is, if I say in the Scotty defect and the Franklin defect, what is there? In the Scotty defect, both the ions are missing. Here, missing, and the ions are of almost equal size. The density in in this Scotty defect decreases. And Scotty defect is seen in the compounds having high coordination number. Whereas in the Franklin defect, the ions occupies the interstitial space in the crystal lattice. The density in the Franklin defect, there is no change in density, and this Franklin defect is seen in the solids which have low coordination. This is all for today. Tomorrow we are going to study about the non-stoichiometric solid defects and the impurity defects. Thank you.